For 7 episodes, we've done this the careful way. We read the spec, modeled the domain, built the write side and the read side, wired authorization and an outbox, and proved all of it with 62 tests. It works. Now the capstone, and it's a genuinely interesting question. We take that exact same spec, not a summary, the real document, hand it to an AI along with the framework's instructions, and say, build the whole thing. One shot. And then we don't ask, is it impressive? We ask something sharper. Could it do it again, the same way, 10 times in a row? Here's the setup. The input is 2 documents. The order management spec we've been building from all series, and the framework's copilot instructions, the same conventions this whole channel teaches. No handholding, no step-by-step prompts. The AI reads both and implements the entire service in a single pass. The domain model, the application handlers, the persistence layer, the API, and the tests. And then we grade it, not against our taste, but against the human-built reference from these 7 episodes, the version that builds clean and passes 62 tests. Does the AI's version have the same value objects, the same state machine, the same authorization shape? Does it build? Does it pass? The spec goes in, a service comes out, we measure the gap. Now the crucial reframing, because it's easy to run this experiment and measure the wrong thing. Any capable model today can produce plausible, working code for a spec like this. That's table stakes. It's not the interesting variable. The interesting variable is variance. If you give an unconstrained model this spec 10 times, you get 10 different services, different folder layouts, different error handling, different ways to model status, different auth. Every run is a snowflake, and a codebase of snowflakes is unmaintainable. So the real question isn't can it build it, it's does it build the same thing every time? And convergence like that is a property of the framework, not the model. Strong building blocks remove the choices. When there's one obvious way to make a value object, one way to handle a failure, one way to authorize, the AI stops improvising and independent runs collapse onto the same design. So we score for consistency deliberately. 57 criteria across 5 levels. Is the structure right? The value objects? The state machine? Is the behavior right? Does approve really require payment? Is the architecture right? The layers, the endpoints, the eventing, are the tests there? Is the framework feedback useful? And a criterion only counts if it holds in at least 7 of 10 independent runs. One lucky pass doesn't count. The bar is 52 of 57. But the check that matters most is scored separately, on top. Add a whole new feature. Order returns, a new status, a reason value object, an endpoint, an event, to the finished code base, with 0 regressions to the existing tests. Because building greenfield from a spec is one skill. Safely changing a living system is the skill that actually pays the bills, and it's the one most likely to expose a framework that only looked consistent. Look back over the series, and you can see exactly why the runs converge. Every episode removed a decision, value objects, and required enum. There's one way to model a constrained value, so 10 runs all model skew and status the same way. Result and railway-oriented programming. One way to represent a failure, so nobody invents ad hoc exceptions. Declared authorization, a mediator pipeline, YEF conventions, the outbox and inbox. Each is a single obvious path, so the AI walks it instead of inventing 5 alternatives. That's the whole thesis of this channel in one experiment. The framework's job is to make the right thing the only easy thing for a human and now for a machine. And here's the elegant part. When a criterion scores low, that's not the AI being dumb. It's a spot where the framework still left too much choice, a signal to go add a tighter building block. The benchmark grades the framework as much as the model. So the finish line is concrete, and it's the same for both. The human-built reference builds clean and passes 62 tests. That's the target. The AI gets the identical spec and instructions, one shot, and its output is scored against 57 criteria over 10 runs, needing at least 7 in 10 on each and 52 overall, and then the returns feature on top with nothing broken. I'm deliberately not going to flash a single model's number on screen, because the honest result isn't a leaderboard, it's a method. The scores that matter are the low ones, run to run, because each one points at the next building block the framework should add. Run it yourself. The spec, the rubric, and the reference are all in the repo, and the whole point is that you can reproduce it. So that's the arc. We read a spec like engineers, modeled a domain that can't hold an invalid value, built a write side that survives concurrency and retries, a read side that stays bounded, authorization drawn as a matrix, and an outbox that never loses or double counts an event. And we proved every bit of it with tests. Then we handed the same spec to a machine and asked the sharper question. Not can it code, but can it converge? And the answer, run to run, is a measurement of the framework itself, a to-do list for making the right thing the only easy thing. That's Trellis, compiler-enforced guardrails for .NET. If you built along, start at episode 1 and do it with me. Subscribe, and thanks for watching the whole series.